So it turns out I lied to you in the last one. I'm not going to give you the crazy ones yet. A couple things I want to do first. Figure let's not ramp it up to 11. Let's just do something mellow. So let's talk about these two functions I got there. They're both chains, but they're to be looked at in two different ways. They're just different. Now the q of x, the one on the right, is actually much more of what I want to talk about. Let's just see the difference. So our outer function is the sine, and our inner function is the x squared. I'm taking the training wheels off a little bit now, and we're going to start running it through. So our derivative on h is, we're going to take a derivative on the outside first. That's cosine. And we're going to leave the inside alone. Now we multiply by the derivative of the inside. What's the derivative of x squared? 2x. There's our answer. We typically don't, we like to leave the trig function at the end, so I'm going to write it just as 2x times cosine of x squared. Good solid answer. Nothing too bad about it. Dope. Let's go. Now we go into this, now q of x, and a lot of us know the notation, and some we don't quite know what it means or can get confused inside of a problem. So maybe we write it like this first. All right, no derivatives or anything done. I just wrote it differently. That's shorthand. The way we write it up top, that's just a shorthand way of writing it. We put the square on the word, saying that the whole thing is being squared, not the variable. So now our outside function has changed. That's a 2. It's something being squared. This is our outside function, something being squared. So that 2's got to fall. We're going to subtract 1 from it, and we're going to leave that inside alone, then multiply by the derivative of the inside. All right, here we go. So our q prime of x is going to be that 2 falls to the front, and then we subtract 1 from that variable, and we get 1. Now we need to multiply by the derivative of the inside, and the derivative of the inside is cosine. Hence we get 2 sine x cosine x. Now if I was to ask you to simplify this completely, you wouldn't be done. Dude, that's sine's double angle. Holy shit, that's just sine of 2x. There it be. So if there is an obvious double angle as your answer, please leave it in the shorthand double angle show. You're a calculus student. Of course you got your double angles on lock. You wouldn't dare walk into your next exam not knowing your double angles now, would you? Or your Pythagorean identities. All right, I'll shut up. Let's go. Let's go. One more thing on trig before I move into a fun-filled little power rolling chain. Let's tackle something like this. Let's say maybe I like h. I like h, and that's not f or g. And let's use one of those weird derivatives, like let's go with like secant, and let's put something strange. Let's put x squared plus 3 inside of here. Now, if you remember, the derivative of secant, right? If you have y is equal to secant of x, its derivative is secant of x tangent of x. Oh shoot, there's 2 freaking x's. Do you just put it to 1? Do you put it to both? Do you just ignore it? Do you just write the letters? You just write tan, like you got a tan with no variable? Of course not. Of course not. So when we go to take our derivative of this, change color, so h prime, we're going to take a derivative on the outside, and that's that secant of whatever's inside of there. So what we're going to write is going to be the secant tangent, but we need to leave that inside alone. So what you're going to get is secant of x squared plus 3 times tangent of x squared plus 3. These aren't like, tan isn't being multiplied by anything. It's tangent of, we got that? And now we can multiply by the derivative of the inside, which is just 2x. Again, my preference, I like to keep my constants and my variables out front of my trig functions, but that's just because I'm a weirdo. It's still correct the other way. So there it is. There would be our solution on that. Careful with those, right? Secants, cosecants. Once we get into inverse trigonometric functions, you're going to find that's going to happen as well. Okay. Choose h again. So if h of x is equal to, I don't remember where I stole this problem, but I like this problem a lot. I stole it from somewhere. Cube, and then we want to we want to find h prime of 4. Is that cool with y'all? Just go find h prime of 4. So let's go take its derivative. But beforehand, I want to get this thing written in derivative friendly. I like derivative friendly before I start. Now, I mean, if you wanted to, you could just do algebra and then we can do the power rule. Do you want to bring this out? Do it 3 times? You can do that. Anytime chance you have to do a power rule, maybe you're like, I'm going to screw up the chain. Bring it out. The only thing that happens is once I put it in and make it the 31st, then, well, now you're kind of screwed. Okay, derivative time. So our 3 is going to fall to the front, and we're going to leave the inside alone. Don't touch the inside until after you've taken a derivative on the outside. Now that we've done that, now we can multiply by the derivative of x to the 1/2 plus x. So the 1/2 falls to the front, we subtract 1, and we get the negative 1/2. There's the derivative of x to the 1/2 of the square root of x. And the derivative of x is equal to 1. Now that's a cool little answer to leave sitting there, but when you actually have to plug in a value, it'd probably be in your best interest to know what all the 1/2s and know what the negatives mean. So let's clean it before we just go plugging in some 4. So maybe we bring it back and then you're like, oh, this makes more sense. This makes a little bit more sense. So maybe we do one of these. Now plugging in 4 isn't so bad. Now taking your 4 and just putting it in anywhere you have an x, that's not so bad. Back here, shoot. So taking that just extra step, write it out. Just leave them blank anywhere I see a variable. This is my style. I like to just leave it blank and then go, oh no, I don't want x. I wanted a 4 in there. So everywhere there was an x, I'm going to replace it with a 4. Now to clean it up. So, PEMDAS. What's that? Square root of 4 is 2, and 2 plus 4 is 6 squared. Times 1 plus, what's that? 1 over 2 times 2, that's 1/4. Oh gosh, so this is going to be 3 times, what's that? 36 times, what's that? 5/4. Let's not make it bigger, let's make it smaller. So that becomes a 9. So we got 3 times 9 is 27, and 27 times 5. 27 times 5, that's going to be 135. I like that problem. Good luck plugging that shit into it. Your calculator and just going and getting it, huh? You got to know something. So these are some of the games we could play. They're not getting too crazy yet. So the next one, now we really will. I'm going to come back. I'm just going to randomly just start writing shit down on the page. Just making problems look as awful as humanly possible and showing that it doesn't matter. We can handle anything with our product, power, quotient, and chain. Little trig. And show how frickin' powerful you've become in our next one. Okay, let's go. See ya.